Section 2.2 Simplifying Radical Expressions. Our objectives are to be able to simplify radical expressions. A radical expression is defined as any expression containing a radical symbol. For example, we have the cube root of 36x to the fourth. The number inside the root, it's called the radicand. This number outside, it's called the index. Now we have some steps for simplifying radicals. The first one is to find the prime factorization of the radicand. So prime factorization. The second step is to determine the index of the radical. The index tells you how many of a kind you need in a group to be able to move the number or variable from inside the radical to outside the radical. For example, if the index is 2, a square root, then you need 2 of a kind to move that number or variable from inside to outside the radical. The third step is to move each group of numbers or variables from inside the radical to outside the radical. If there are not enough numbers or variables to make a group, then leave those numbers or variables inside the radical. Notice that each group of numbers or variables gets written once when they move outside the radical. Our last step is to separately simplify the expressions both inside and outside the radical by multiplying. Let's take a look at example 1. Simplify the following radical expressions. Our first example is the square root of 252. So the first step is to find the prime factorization of the radicand. To find the prime factorization, we need to find two numbers and multiply to 252. We can organize using a factor tree. So two numbers and multiply to 252. In this case, we're going to use 2 times 126. Now the 2 is already a prime. We cannot factor it further, but the 126 we can. So 126 is going to be 2 times 63. Again, the 2 we cannot break it down further, but the 63 could be 7 times 9. The 7 is already prime, but the 9 we can break it down further, which is going to be 3 times 3. Now the prime factorization consists of all of the prime numbers from the factor tree. In this case, it's 2 times 2 times 7 times 3 times 3. All right, so for our second step is to determine the index of the radical. In this case, when we don't have an index outside, it means it's a square root. So our index is a 2. All right. Now we're going to use the prime factors and rewrite the 252. So this is going to be 2 times 2 times 3 times 3 times 7. Since our index is a 2, this means we will be looking for groups of 2 inside the radical. So we're going to make groups of 2. We have a group of 2 2s and we have a group of 2 3s. The 7 is by itself, so we cannot make a group. So step 3 is to move each group of numbers from inside the radical to outside the radical. Each group of numbers gets written once when they are moved outside the radical. So this is going to be 2 times 3, the square root of 7. Again, we only write it once we took it out the radical. And then my fourth step is to simplify the expressions inside and outside by multiplying. So here we're going to multiply 2 times 3 is 6. The 7 is by itself, so that stays inside. For example B, we have the square root of 180. So we need to find the prime factorization of 180. So two numbers that give me 180, when I multiply it, we're going to use 10 times 18. 10 is 2 times 5, and 18 is 2 times 9. Now from here, the 2 and the 5 are already prime numbers, and 2 times 9, I can break down the 9. So 3 times 3. All right, so that means that my prime factors are going to be 2, 5, 2, 3, and 3. Now let's take a look at our index. Again, if it doesn't have it, it means that it's a square root. So my index is going to be 8, 2. That means that we're going to be making groups of 2 inside that radical. All right, so let's rewrite the 180. So we have 2 times 2 times 3 times 3 times 5. Again, we're going to be making groups of 2. So we have a group of 2 and a group of 3s, and we're going to write it outside the radical once. So 2 times 3, and the 5 stays inside. Then we got to simplify by multiplying 2 times 3, 6. So 6 square root of 5. Example C is very similar to A and B. So this one you can go ahead and try it out on your own. So this one, try it out. All right, now for example D, I have the cube root of 54. We're going to do the same thing. Find the prime factorization of 54. So two numbers that when I multiply them give me 54. It could be 6 times 9. 6 times 9. And I can still break down these numbers. So 6 is going to be 2 times 3. And 9 is going to be 3 times 3. So the prime factorization, it's going to be 2 times 3 times 3 times 3. All right. Now for my index, right here my index is 3. That means that we're going to be making groups of 3. So I have the cube root of 54, which is 2 times 3 times 3 times 3. Again, we're making groups of 3. So in this case, I have a group of 3 of 3's. And remember this one, we're going to take it out once, only once. So I'm going to write 3, and then we write our radical symbol with our index. And I have a 2 left inside. This is my final answer. Let's take a look at example E. Example E has variables inside my radical. So for this one, we're going to find the prime factorization of 243, and the variables will be written out in the prime factorization. So two numbers that when I multiply give me 243. So 243, it's going to be 3 times 81. 81 is 9 times 9. And 9 is 3 times 3 and 3 times 3. That means that my prime factorization for these are 3 times 3 times 3 times 3 times 3. All right. So for this one, my index is 5, which means we're going to be making groups of 5. All right. So let's take a look at that. So I have 3 times 3 times 3 times 3 times 3 times x to the 7. X to the 7 means that we're going to have x times x times x times x times x times x times x, which is 7x, times y to the 8. So 8y's 1, 2, 3, 4, 5, 6, 7, 8. All right, so we're going to be making groups of 5. So we can make a group of 5 with the 3's. So 5, and then 1, 2, 3, 4, 5 with my x's, and 1, 2, 3, 4, 5 with my y's. Remember, we're gonna take out one of them. We're only gonna write it once outside. So we take out a 3, an x, a y, and inside we have left x squared, because x times x is x squared, and y to the 3rd power. Okay? So this is our final answer for example E. Let's take a look at example F. So find the prime factorization of 216. So 216. Two numbers that when we multiply them give me that. So 3 times 72. 72 is 8 times 9. 8 could be 2 times 4. And 9 is 3 times 3. And I can still break down the 4, which is 2 times 2. So our prime factorization is going to be 3, 2, 2 and 2, 3 and 3. All right. Now let's take a look at our index, which is the one that's going to tell us what groups we need to do. So my index, it's a 2. All right. So let's go ahead and write this. So I have 2 times 2 times 2 times 3 times 3 times 3. And then we have x to the 5th power. So that means we're going to write down 5 x's. So 1, 2, 3, 4, 5. And we have y to the 8th power. So we're going to write 8 y's. So 1, 2, 3, 4, 5, 6, 7, and 8. Now, since my index is 2, we're going to be making groups of 2. All right, let's take a look at that. So I can make a group of 2 of these, of my 3's, my x's. Or take a look at that. We can make 2 groups with my x's. And my y's, I can make 1, 2, 3, 4. All right. So remember, when we take them out, we write them out once. So we have 2 times 3 times, we have 2 groups of my x's. So it's going to be x squared. And then for my y, we have 4 groups of the y. So that's going to be y to the 4th and the square root. What do we have left inside that square root? We have a 2, a 3, and 1 x. So we have 2 times 3 times x. So let's simplify this by multiplying. 2 times 3 is 6, x squared, y to the 4th. That's square root of 2 times 3 is 6, x. And that's my final answer. All right, for example G, this one you can go ahead and try it out on your own. So example G, try it out. All right, so example H, let's find the prime factorization of 176. So 2 numbers that when I multiply them give me 176. It's going to be 11 times 16. Now, 16 is also 8 times 2. 8 is 2 times 4. And 4 is 2 times 2. So our prime factorization is going to be 11, 2, 2, 2, and 2. Let's take a look at our index. What's our index here? Our index is going to be 4. So that means we have to make groups of 4. So we have the 4 root of 2 times 2 times 2 times 2 times 11. And then we have x cubed. So we're going to write 3 x's, 1, 2, 3. and y to the sixth, so 6y's, 1, 2, 3, 4, 5, and 6. Let's go ahead and make groups of 4. So I can make a group of 4 with this, not with the 11, not with the x's, but I can make a group of 4 with my y's. So we're gonna have a 2 outside and 1 y outside. And then we have the fourth root of, what do we have left inside? We have 11, and we have x times x times x, which is x cubed. And we have y times y, y squared. And that's our final answer. So for example, you can go ahead and try this one out. So for example, I try it out. Now let's take a look at example J. Let's find the prime factorization of 294. So two numbers I multiplied gave me 294. I'm going to use 2 times 147. 147 could be 3 times 49. And 49 is 7 times 7. So my prime factorization is 2 times 3 times 7 times 7. And my index here is 2. Remember, if it doesn't have it, it means it's a square root. So my index is a 2. All right. So this is going to look like 2 times 3 times 7 times 7 times x times x times x times x. And we have y to the 9th. So 9 y's. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Since my index is a 2, we're going to be making groups of 2. I cannot make a group with the 2 or the 3, but I can the 7, the x's, and the y's 1, 2, 3, 4. All right. So this is going to look 1, 7 outside. And then we have x squared because we have two groups. And then we have y to the 4th. And inside we have 2 times 3 and a y. 2 times 3 is going to be 6y. And that's our final answer.